In a previous lecture, we discussed about cloud computing and its importance in Internet of Things. So, cloud is very important because you see that Internet of Things IoT devices, sensors, RFID devices and so many different types of devices, they send so much of data and finally those data have to be handled, and that is the reason that cloud came into picture, that all these data will be sent to the cloud for further processing and so on and so forth. Now, the main problem with cloud in Internet of Things environment is that latency. So, what is meant by latency I will explain to you before we go formally about discussing the concept of fog. Is that let us say that we have a cloud and we have different IoT devices deployed. Now, what we have discussed when we were talking about cloud computing in the context of Internet of Things is that each of these devices, they send all these data to cloud for further processing and storage, Now, that is a problem, because you see these IoT environments, number one, are constrained in different ways with respect to bandwidth, with respect to processing, with respect to memory, with respect to energy and so on and so forth. Now, this processing can be handled with the help of cloud, but what about the bandwidth, what about the energy consumption? Because what is going to happen in this sort of scenario of use of cloud in the IoT context is lot of data is going to float all around. Over the network, lot of data through the internet are going to be sent to the cloud, and that will unnecessarily consume the bandwidth, that will also consume unnecessarily the limited energy that is resident in all these devices and so on. So, we do not want to do that, because communication consumes most of the energy. So, we do not want unnecessary communications to take place, and even if we do, we have to limit, even if we have to communicate, and that is required, because in a network basically IoT is basically a network. So, in network communication is required, but how do we handle it efficiently? This is what we are going to discuss in this particular lecture. So, can we do something which is better than cloud? So, this is where fog comes into picture. Fog was introduced by Cisco, and so it was sort of like an idea about how to bring the cloud facilities close to the IoT devices, because as we saw that we have to have all these data sent to the cloud, that will that will not only take the bandwidth, limited bandwidth that is there in this kind of environment, but also that is going to take lot of time. So, So, in this particular case, the time that is required will be the time from when that event is sensed, that piece of data is sent to the cloud. So, this one, let us say this is T1, this is T2, then the time for processing T3, and finally, that response will be sent back, right. So, T4. So, the response will be sent back for maybe actuation or something like that. So, this basically becomes T1 plus T2 plus T3 plus T4. So, this is the total time that it takes until when the receiving device gets a signal about what to do, and by such a time, in most of the real life applications of IoT, by this kind of time, the most of the the events, most of the unwanted events would take place. For example, if it is a surveillance application, maybe the intruder by this time, because there is so much of latency that is involved, by this time the intruder might have already intruded into the territory. Or if it is a medical emergency scenario, by this kind of time, the time it takes to send it to the cloud processing it, getting a response back, etc., etc. So, the real timeliness is going to be lost, and because of this particular issue, what is going to happen is, if it is a medical emergency situation, the patient might die, right. So, what is required is, can we reduce the latency, and this is what we are trying to do in fog computing. So, as I said, that fog was basically proposed by Cisco, and the whole idea is, can we bring the cloud facilities, the attractiveness of cloud closer to the IoT device layer, and the whole idea is to solve the problems that are faced by cloud computing for use of IoT for data processing. So, this is the whole objective of fog computing, and the whole idea is also to reduce the delay that is incurred in sending the data from the sensor device to the cloud, from the cloud getting a response back and actuating the particular device. So, can we reduce this particular time? So, this is the whole idea, the whole premise under which the fog computing works. So, conceptually, what we used to have in IoT and cloud, this is the device layer where all these IoT devices, the physical devices operate. This is the cloud where all the data are sent for processing and storage. So, what fog is saying is, it is going to be sort of like a middleware, or a middle layer rather, where some of the computation, some of the processing, some of the storage, at least transient storage, is going to happen before the data that is sensed by these devices are sent to the cloud. Before it is sent to the cloud, can we do some intermediate processing, intermediate storage for quicker decision making. This is the whole idea behind the use of fog computing. So, let us go back to some statistics, some of which we also went through at the beginning of the course. So, we know that nowadays, because of all these different sensors, etc., there is a lot of data that is floating all around. So, it is estimated that by around 2020, 40% of the world's data will come from sensors, and 90% of the world's data will be generated only during the period of last 2 years. Okay. So, 90% of the world's data was generated only during the period of last 2 years. So, it is also estimated that every day about 2.5 quintillion bytes of data is produced, and the total expenditure on IoT devices will be about $1.7 trillion by 2020. So, given all these different statistics, we now have to think about an architecture of Internet of Things, wherein we can use all these different devices in a scalable manner, such that the processing happens with large number of devices in a quicker manner, and in an efficient manner. The total number of connected devices, the total number of connected vehicles worldwide will be about 250 million by 2020 as per estimates, and there will be more than 30 billion IoT devices again as per estimate. So, the amount of data that is going to be generated by these IoT devices is obviously quite huge. So, how do we handle this kind of huge data? I mean, one way is basically to use all these big data analytics and so on, but even before that, can we reduce the processing time of this data? Can we do something from the network point of view? And that is where we have to take help of fog. So, why do we need fog computing? Because cloud has certain deficiencies. It is insufficient to handle the requirements of IoT. So, there are issues with volume of data that is produced by the IoT devices, the latency, that means the time that it takes for a sensed data to go to the cloud and then come back, that duration is the latency, and the bandwidth. Bandwidth means that how much how much data is going to how much the channel is going to be occupied because of this communication of all these data from the IoT devices. So, the fog computing architecture looks like this. So, we have all these IoT devices, and we have the cloud. So, as I said, traditionally we have to use these IoT devices to sense the physical phenomena occurring around them, send the data to the cloud and get an action or command back. So, as we can see over here that this is the traditional cloud model. And so, why we need fog computing? Because we want to reduce this particular time, and typically these cloud servers might be physically located even continents away. It is typical to have them in different cities and so on, but even continents away also. So, this physical limitation also introduces large latency in communication. So, in terms of the data volume, it is estimated that by 2020 about 50 billion devices will be online, and presently billions of devices produce exabytes of data every day, and this is this big data, right. So much of data is going to be produced every day, not only every day, every second, every minute, so much of data, unusual volumes of data are going to be produced because of the introduction of Internet of Things. Exabyte means what? 10 to the power 18. So, we have gigabyte, terabyte, petabyte, zettabyte, exabyte, right. So, typically we used to use traditionally with gigabytes of data maximum, but nowadays with Internet of Things and so on, it is very common to have terabytes, zettabytes, exabytes of data that is produced every day, and to be to handle this kind of data volume. So, the device density is also increasing every day. So, the current cloud model is unable to process this amount of data. So, the private firms, factories, aeroplane companies, they all produce huge volumes of data every day. So, if you look at this particular figure, this will be clear. So, we are not talking about data produced by a single firm, we are talking about data that is produced by several firms, and the different devices that are used in those firms, the IoT devices, the embedded systems devices that are basically used in those firms. So, several huge volumes of data are produced every day by a single firm, and definitely large number of firms also produce large volumes of data. Factories, the same kind of thing, factories also produce large volumes of data. Aeroplane companies, airplanes themselves have lot of different types of sensors, they also produce large volumes of data. So, all these data would have to be sent to the cloud for further storage and processing. So, the current cloud model that we have already gone through in the previous lectures on cloud computing cannot basically store all these data. So, this data that is produced, the raw form of data, has to be filtered before the data is sent to the cloud. So, this has to be pre-processed, filtered before it is destined for storing and processing in the cloud. In terms of latency, lot of time being taken by a data packet for a round trip, and this is what I was explaining to you with the diagram that I showed at the outset. So, an important aspect for handling time sensitive data is basically to handle this issue of latency, because if it is time sensitive, it is real time data. So, time is important, and that is the reason why latency has to be handled with special interest. If the edge devices send time sensitive data to the cloud for analysis and wait for the cloud to give a proper action, then it can lead to many unwanted results. So, while handling time sensitive data, a millisecond can make a huge difference. So, look at this particular figure over here. So, ambulances, then different buildings and different other different other devices and so on, cars and so on. So, they basically generate data which are time sensitive in nature. So, they basically generate data which are time sensitive in nature, and so that is the reason why they have to be processed pretty fast to be able to use the data in a meaningful manner. So, they have to be processed pretty fast. So, ambulance for example will generate some data. So, the time that it takes the data for the data to go from here to the cloud and come back, this can be represented with this this can be shown in the form of this kind of equation. So, latency equal to the time it takes for the data to go from the device, that means the IoT device, to the cloud, plus the time for data analysis, plus the time it takes for the data to travel from the cloud to the device. So, latency will be increased, and when the action reaches the device, accident may have already occurred if it is an emergency situation or a connected vehicle situation. So, this is the reason why fog computing is very important. So, in terms of the bandwidth, the bit rate of data, in terms of the bandwidth is calculated as the bit rate of data during transmission. So, if all the data are generated by IoT devices and those data that are generated by these devices are sent to the cloud for storage and analysis, then the traffic generated by these devices will be simply gigantic. So, these IoT devices are going to consume almost all the bandwidth because of this, and handling this kind of traffic will be simply a very hard task. So, billions of devices consuming bandwidth, if all the devices become online, even IPv6 or IP based technologies will not be able to handle the facility to all the to provide the facility to all the devices, and the data may be confidential, which the firms do not want to share online. So, these are the different problems. One is the privacy of the data. This is of concern to the firms. The second is that dealing with these kind of problems with IP based technologies like IPv6 is a problem, and also the issue of having billions of devices consuming bandwidth. So, how do we handle them together in a synergistic manner? Reduced latency of data, appropriate action at the right time prevents major accidents such as machine failure and so on. So, a minute delay while taking an action makes a huge difference, and this is what I was explaining to you during the medical emergency scenario. A person might die, a person might completely die if the decision making takes lot of time compared to the time for sensing. So, it has to be the time for decision making, that means processing, storage, etc., should be conformant with the time for sensing. So, the time it takes for sensing. So, almost after something is sensed, immediately thereafter it has to be disseminated, and corresponding action also has to be taken in real time. Data security, IoT data must be secured and protected from the intruders. Data are required to be monitored 24/7, and appropriate action should be taken before the attack causes major harm to the network, and this is what I was explaining to you. And the operational reliability, the data that is generated from the IoT devices are used to solve real time problems. The problems of integrity and availability of data must be guaranteed, and unavailability and tampering of the data can be hazardous. Processing of data at the respective suitable places. Data can be divided into three types based on the sensitivity. One is time sensitive data, second is the less time sensitive data, and third is data which are not time sensitive at all. So, this kind of filtering has to happen with respect to the sensitivity of data. So, extremely time sensitive data should be analyzed very near to the data source, and data which are not time sensitive will be analyzed in the cloud. So, time sensitive data closer to the devices, non time sensitive data send it to the cloud. Monitor data across large geographical areas. The location of the connected IoT devices can be spread across a large geographical area. Example, the monitoring the railway track of a country or a state. The devices are exposed to the harsh environmental conditions additionally as well. So, when should we use fog? If the data should be analyzed within a fraction, a minute fraction of a second, if there is huge number of devices in the network, if the devices are separated by a large geographical distance, or if the devices are needed to be subjected to extreme conditions. So, with this we come to an end of first part of lecture on fog computing. In this lecture we have understood what fog is, the genesis of fog computing, and also about how fog computing can help in building Internet of Things systems. We have also in the process gone through some limitations of the use of IoT.